Welcome to this video where we'll take a look at trig functions of any angle. We're going to actually start by looking at special right triangles, and then we'll start looking at them combining with the last section where we looked at any angle on the coordinate grid. And so we cover a lot of ground in this section and the last section, and it's really kind of the foundation of our trig section. So really encourage you to invest some time in it, make sure you understand it. Please reach out to me if you've got questions. So we're going to start by taking a look at what we call special right triangles. We call these special right triangles because in these triangles we have congruent angles here, 45 degrees and 45 degrees, which means that we have two congruent legs. Now, for this example, I'm going to pick and say, let's let this side be 1. We could have made it anything, but for my example, I'm going to choose 1. If we're going to make that 1, then this leg is how long? Well, since they're congruent, since these angles are congruent, these opposite sides have to be congruent. Hopefully that makes sense to you. And now I want you to find the hypotenuse using our trusty Pythagorean Theorem. Some of you already know what this is going to turn out to be. If we take the square root of both sides, x ends up being the square root of 2. And the cool thing about this is no matter what I pick for these, they will always be in the ratio of 1, 1, square root of 2. So let's just try that. If instead of putting 1 here, I would have put the number 3, what would we end up with? Well, this part's going to change. 3 squared plus 3 squared, that's 9, and 9, that's 18. X is the square root of 18. And if we break 18 down, we get 9 and 2. That's going to give us 3 square root of 2. Now, notice they're still in the ratio of 1, 1 square root of 2. In other words, if I would think of these as fractions, and I would simplify them, 3 square root of 2 over 3, I'm left with square root of 2 over 1. Still the same ratio, and we'll look at that more a little bit later. If that confused you, don't stress about it. The main takeaway that you need to have for this picture in your mind is you need to recognize that anytime we have a 45, 45, 90 triangle, the sides are in the ratio of 1, 1 square root of 2. I say it's as easy as 1, 1 square root of 2. Now, let's take a look over here at this triangle. This is an equilateral triangle. It's got 3 60-degree angles. Again, like the last triangle, I'm going to pick the side. This time I'm going to make it be 2 instead of 1. And now I would like you to think about cutting this triangle down the middle and making a right angle. So now instead of 60, I've got what on either side here? Hopefully you're thinking 2. And now I want to zoom in and just look at one of those triangles. You know what? Notability has this cool feature. You don't have to look at my crooked lines. I can make them straight. Reminds me of Jesus. He said he would make the crooked places straight. Actually, Isaiah said that about Jesus, but anyway, here we go. This side is 2. What do you think this bottom leg is? Hopefully you're looking over here and saying, well, we cut this in half here. This will be 1, this will be 1. So this is 1. And then you need to find this. And again, we can use our handy-dandy Pythagorean Theorem. This time I have the hypotenuse, so when I simplify, I end up with x being the square root of 3. Okay. All right, so for 30, 60, 90 triangles, the same thing, I don't want to say the same thing as the 45, 45, 90 triangles, but just like in the 45, 45, 90 triangle, we had a ratio that's the same no matter what. We have the similar ratio that's the same. We have a ratio that's the same for the 30, 60, 90 triangles. The 30-degree angle is always opposite the shortest side. The shortest angle, shortest side. The medium angle, the medium side, square root of 3 is approximately 1.73. And the biggest angle, 90, is opposite the biggest side. All right, so takeaway. What do I want you to know for this one? I want you to remember that for a 30, 60, 90 triangle, there's a ratio that is 1, 2, square root of 3. I say it's as easy as 1, 2, square root of 3. You just have to remember where they go. So either through just using this or using the Pythagorean Theorem, this is important for you to know. We are going to use this information quite a bit in the next few sections. So if you need to memorize it, put on a note card, whatever, that's fine. We've got on a 30, 60, 90 triangle, as easy as 1, 2, square root of 3. 1 is the short leg, 2 is the hypotenuse. Remember, we chopped it on the triangle here. And then square root of 3 on this side. Over here, 45, 45, 90 triangles, as easy as 1, 1, square root of 2. Makes sense, the bases or the legs here are going to be the same. Those are going to be my 1s, and then the square root of 2. And if you need to, you can always use the Pythagorean Theorem to help you. But you will need to know these for the exam.